Okay, now it's time to model out our interior part. So let's work on this glass circle. This is where our LED lights will be located eventually, right? So let's make this kind of extrusion, circle extrusion inside. So I can grab this glass piece here, and then I think it's a good spot to branch off on here. So let's start simple with a circle. Okay. Increase the divisions. Okay. And then uniform scale. Let's make it much smaller. Like that. This direction is already good for us, facing towards Z. And then let's extrude it out. Enable the output back. And we can link actually the extrusion to the extrusion of our initial box. Let's just find it. I think this was the front extrusion, right? So we can grab these. And stick it into our distance. Yeah. In fact, let's grab it. I would say this was the height, not the, see, I think, yeah, that's the one. Let's better grab this one. Delete and paste again. Okay, now this is the one. Okay, so let's use match size. And then we will put it inside of our glass. Okay, so this one will go here, and this one will go here. So it places it inside. Now let's use Boolean. On here. Use it like this. Okay. In here we can also, let's see if we do multiply by 2. Can make it deeper. And then we go to circle and change the center. On Z we can also, we should be able to, if we control this. First, let's say that justify Z is none. So when you match, it's not modifying anything on the z-axis. Okay, and now if we pick z-axis, then we should be able to control the depth of it. Okay. Let's see. Now, let's have a look. Let's template our boxes. See what's happening. So this is our circle here. If I were to also enable, let's enable our pole, because eventually we will have like a pole running through this hole, right? Where we're gonna hang up our traffic boxes. Okay. So if I were to put it here in the match size, let's disable and then put it here. So let's see. When we change here the protrusion, you see this pole is kind of clipping here, right, through our mesh. And that is because at the moment, our glass piece is it's totally square, so it's symmetrical, right? However, if you have a look at our references, actually, let's take a look at another picture that is a bit better. Like for example, here, you can see that the width is a little bit more elongated, so it's tiny bit higher than our height, right? So it's not a perfect square. And we always see that, also see that our circle here, it's a little bit moved to the right side, you see. And I think that's the main reason why it's been done like this, because as you can see, there's like this pole, right, running all the way up. And so this way it's not clipping through the lights and the circle, and that's why it's displayed like that to the side. So let's do the same. So what I would like to do first is let's go back to our initial box that we used to set up our glass cutter here, right? And in the size, let's elongate it a little bit. We can just add a tiny bit to the side. So we elongate it, okay? And also let's move our circle to the right. You can do it in the match size. We can push it a bit like that. So here I don't need the depth to be so big, so I'm gonna push it in kind of like that. And then in the match size, I'm gonna move it like this, more or less, so nothing is clipping. Yeah. I think it's pretty good like this. Right, so now that this one is sorted, let's remove this template and then now let's working on the remeshing. To get rid of all this weird geometry that we have going. So initial remesh completely destroys my shape, but let's change the target size. Something smaller, which gives us more resolution. So let's see, like something like this. We can also play with the smoothing. Okay. You can also drop subdivide before I remesh like this. Let's see our smooth shaded. Probably we have a problem with normals. Yeah. Okay. So let's drop a normal. There you go. By face area. Okay. Also, if for you it is too dense, you can always use poly reduce node. For example, you wanna on these flat areas over here, there's no need to have so much geometry, so what you can use poly reduce to decrease it, in the flat areas, especially like this. Feel free to try this node. Okay, so after remesh, I'm gonna just do a bit of a bevel. Gonna use exclusions. So I just catch these edges. Okay, then something like this. Bit of a bevel. Let's see. Smooth shaded view. If I catch it, okay. Push it down. Like this. Yeah, perfect. So it catches my edge. Nice. Okay. I'm gonna also this container, I'm gonna group it because I think it's good to have it for later on when we're placing our LED lights. I'm just gonna group it. Call it LED container. Okay. Now, also gonna push this container a little bit back. So it's not clipping through my glass. Transform. Okay. Okay. So then let's do the final naming. folder. Okay. There we go. All right, so let's move on to the next part. Now I'm going to model this little device here. I didn't know about it, but I went into the website and I found out that these are actually like little speakers for that is used for blind people. So when blind people they cross they cross the pedestrian section, right? And they use those sticks that help them to navigate when they walk. And there's like a little chip inside of those sticks that this device inside detects and start beeping, so it helps them to cross. So it's pretty fascinating stuff. Really cool idea. So I thought it would be nice as well to include those this little elements, you know. So let's see how we can approach building that. So again, let's start simple. Um, we can build a circle, or I thought maybe a better idea will be to start with a grid, and I'll explain why in a bit. So let's just go with the grid. Okay. So that's our grid here. Let's set it like that. And then also let's reduce the size. It's spacebar G to zoom in. Okay, and here I'm going to I'm gonna set rows at 12 and then columns I'll reduce it to 2. So we are only left with horizontal lines here. Now I'll follow up with this one, circle from edges. That will convert a grid into a circle. The reason I'm doing like that because it will help me to extract these horizontal lines here, which then we can convert into like little, and convert into capsules, for example, and then subtract from our main shape, you know, to achieve something like that. Like we have a grid here. Okay, so we can output edge group. Just gonna call it alter. Then I will extrude. Let's output back. Okay. Now, just want to be left with edges. I will use a convert line. And in here we say everything except for our outer edges. Like that. And then let's also remove unused points. All right, great. Now, we can use the sweep. You can say round tube. And it like this, and then we can enable the end cap. We can say grid. So for example, we have that, and then Boolean subtract. Okay, so when we subtract like this, you can see it does the job, but I would like to be able to control, you know, the length of those capsules. For example, we can obviously, you know, we can see, we can go here and, you know, dial it back. But, you know, in my opinion, it's better to have a fine-tuned control, like to be able to control the upper side, the middle, and the down the bottom as well. So I think what we should do really is to apply a different approach here. So we're gonna grab these ones here, okay? And what I would like to do is to find the center point of each line here, okay? So we can use a centroid for that. Extract centroid. Okay, we're having nothing is happening. We are having an error because extract centroid also needs to know that all these lines are separate, not as one. Okay, so what I'm gonna do is I'm gonna drop a connectivity node. And then extract centroid. The connectivity has this attribute called class. So I'll go to extract centroid, put here class as well. And connectivity, let's make sure it's the connectivity type is not point, but the primitive. So each line. So we change to primitive. And here you see now we're having the points, middle point on each line here, like this, okay? I'm gonna connect them. So let's see, add. Add. And then we connect them like this. And now what I'm gonna do is I will create another line. You'll see in a bit why. So I'll do the line. Again, it's let's make it 0.1. I will set the direction to X like this, and I'll center it again. So it's in the center. And then I'm gonna sweep it now. I'll sweep it. I'll keep the surface as a second input, cross sections, and then I'll change it to rows. So we have that. And the reason I'm doing it like that is because in sweep, there's a really nice function called apply scale along curve. If I enable that, I'll be able to adjust the length of these lines. And I have a, now if I click on this point, let's make it B-spline so it's smooth. B-spline. I will add another point here. Now you can see now we're able to control, the length, like on top, in the middle, and at the bottom. So this is the middle. For example, we can set any profile we want, which is pretty nice. We can also control like the overall length with this one here, like that. So we say sweep length, this sweep capsule. And now we're gonna put it here, have our capsules. I'm gonna subtract. Okay, now if we go back to the length, see we're now able to adjust the top here, the bottom and the top. I can even link them together. So for example, I can just copy this and then paste it here. So these 2 points are symmetrical. Okay. Okay, so what I'm noticing as well, let's have a look at our reference. Drag it over. Like these horizontal lines, they have a equal spacing between them, and ours is kind of starts equal in the middle, but as long as when it's going up, it starts to like squash, right? There's almost no space between those. So I'd like to be able to equalize it as well, So there's one really nice note we can use is edge equalize. Let's enable points to see better. You see, it actually equalizes the points, so they have the same spacing. Now I see if we disable without it and with it, are the same. I also would like to get rid of this, the very top and the very bottom line, because it's clipping through, so we don't really need those. So what we can do is drop a range. So range, let's say here, and then we invert. Let's call it outer lines. We blast them. We are just left with this. Yeah, I think it's better this way. Gonna make a small adjustment. I think that is cool like this, yeah. So in here, I will apply a little bevel. Exclusion. Yeah, that should be fine. Okay, let's also center this piece. So it's sitting at 0 coordinates, which you can use center. They will also center our pivot. So, okay. Now it's time to divide. Divide our mesh. Okay. To check the smoothing. And then by face area. Okay, great. So yeah, we have our speaker here. Now let's check for our size. So I'm gonna also use a fuse sub just in case. Okay, now let's enable this. So yeah, it's quite big at the moment. Once we place it on our glass part, we will be able to also, adjust the size. But for now, I'm just gonna eyeball it a little bit. Or something like this for now. Okay. And now let's place it onto our glass, right? Oh, let's move it here. Let's call it speaker. I'm gonna go back to the glass and then let's see this area where we have our. I'm gonna disable this. Yeah, we can grab this piece over here, and then let's place our speakers. Like I think there are two of them. Let's have a look. So yeah, we have one in the left bottom corner and another one in the top right. So let's see how we're gonna go about doing this. So the first thing that comes to mind is again match size. So do match size. And we have our speaker. Here. So with the X, we can do minimum to maximum. So it's what you see is that in here, since we are let me just check it here. Then see minimum to maximum. Okay, that's a better example. So yeah, it's adding it on top of our glass surface, but the thing is, since our glass is curved like that, you see And match size is using the bounding box of our curved mesh. You see the speaker is kind of floating, right, in the air, so it's not following the curvature. It's not following the curvature of our glass. So how can we fix that? Okay. Well, one way is to use a ray SOP. What it does is like it takes an item, shoots a ray, and then it kind of like the item gets stuck to the surface. That's the idea. Let me just demonstrate. Just make some space here. What we can do is first add a point. Add a little point here. Let's see. Let's enable the number. And we say 1. Okay. So here's our point here. Okay. Now we're gonna add it first to our match size. Okay, so here it is. So it's floating, as you can see here, right? Now, let's use our ray SOP. Ray. Then we have our glass. Now we need to switch from project rays to minimum distance. It gets attached to our glass surface. Okay, now let's test it if it's working. Like, for example, if I move X, see now when I move my X, it's following the curvature of the glass, which is what we need. Great. Okay, now then let's see if we can use copy to points to copy our speaker piece onto this point. Our speaker. I'd rather switch these ones. Wait, it's the other way around. Okay, like this. Okay, so let's see, it's copying it. However, like when we move, it seemed to be like facing Z direction, but it's not turning, right? It's not respecting our curve. That's why you see it's like entering into our glass here. And the reason for that is that we don't really have any normals on our surface. So the speaker doesn't know which direction to face, really, you know? If we enable, let's see. If we enable our normals here, there is some information like on these points, but since we don't have any points in this surface, our speaker doesn't know, really, our piece doesn't know which way to face. So let's add some more geometry to our surface. We will find our glass and then let's undivide. Divide. And in here, I would like to use pre-curve polygons instead of triangulating. So for example, if I were to set something really small here, like that, you can see it subdivides creates those squares. Not even more here. Okay. And now I'm going to add normals here to our points. So points. Let's enable normals. Now we have much more information on our surface, you know. So let's see what happens now. When we go to our array, for a point, if I enable this normal, you see our point here doesn't have any normal because we need to scroll down in array and take this import attributes from hits. So then the point will inherit the normals from the incoming geometry. Okay. Once we do that, see if I were to move it across the surface, it inherits everything from the background geometry. And that should help us really with facing, you know, the direction. So let's have a look. Go back to copy 2 points. Let's enable this. Okay. Now, so now it's much better. You see, the speaker, when I change it, it kind of like glides along the surface. This is what we need, and it's also is aligned the direction of the glass. Just have this little issue that when we get close to the edge, it's turning like this. So one way to mitigate this is just to delete one side of the glass. Here, so go by normal. Okay, now we delete that. Okay, let's see. Oh wait. And now it's not doing anything weird on the edges. And we can just control like how it slides. Okay, nice. So let's say this much size is to position left speaker. Duplicate. And this one will be to position the right speaker. Speaker. Can merge this together. And then put into array. Okay. Let's see, adjust this one. Right side. Put in the top right corner. Like that. Just check, I'll check later, like the real photos. More or less adjust how it looks. So yeah, I think it's pretty good. Okay. We have, let's disable this. We have our speakers. Let's finish this off. I'm gonna wrap this up into the network box. Speaker placement. Let's have a look how it all comes together. So these are LED holder. Put it here. Then see, we have our speakers here as well. Okay, nice. Just gonna lower the bottom a little bit. Like this. Okay, cool. Okay, so in the next part we will be doing we'll be placing LED lights inside of this circle.